The topic of this video is Formula E electric vehicle racing and how developments in the technology are filtering through to everyday production vehicles and moving forward the advancement of electric vehicle production. Our guest was Sir John Samuel, who is an electric vehicle pioneer with an outstanding record of innovation in the automotive and power storage industries. He built and raced GT cars in the 1960s, developed the UK's Enfield 8000 electric passenger car back in 1970, and headed the Electric Auto Corporation team in Detroit in the early hybrid vehicle development, successfully overcoming the limitations of lead-acid batteries in electric vehicles. In 1990, his team won the City of Los Angeles Electric Vehicle Initiative and launched the LA301 plug-in hybrid in Tokyo. And that was the inspiration for the Toyota Prius, which went on to become Japan's best-selling car. And all that was before the advent of lithium-ion batteries. But bringing that right up to date with Formula E technology, we heard a fantastic presentation from Sir John, and he covered, using some stunning visuals, racing and the rules and the teams in racing, the electronics, a little bit about the chemistry, as well as talking about a few overexcited commentators. At the end of the presentation, we continued our recent theme of the videos and webinars, where I was lucky enough to be in conversation with Sir John along with members of the team who put forward questions from the live audience. During that, we talked about topics ranging from driverless cars, the changes coming next season in Formula E, and then put forward questions from the live audience on topics ranging from the effects of temperature on charging, the effects of performance versus life on the batteries, whether there's enough source of lithium in the world to keep electric vehicles rolling out for everyone, and then the implications of recycling all of those rare earth materials when they come to end of life. And we also speculated a little bit on the future for Tesla. Have they got the right formula, and will they be able to keep at the leading edge of electric vehicle development? So for all that and more, do keep watching, and I'll now hand over to Sir John and his presentation.
Okay, Nigel, thank you. Good evening, ladies and gentlemen. It's an absolute honour to be talking to you about my two lifelong interests, which are motor racing and electric cars, especially at a time when damage to the environment and cleaning up our transport has become such a vital importance right now. I hope you're all receiving me loud and clear, and thanks to the wonders of the internet, I may be talking to some of even my son over in Chicago and in Michigan, which is amazing. And also, despite the steamy hot weather, which is all a sign of climate change, I'm sure. And it was actually Peter Ricardo at the IMechE who, in the midst of the pandemic, had the inspiration to point me in the direction of Formula E. And it's at the cutting edge of EV development. And it's turned out to be a fascinating journey. Also, I do want to thank Colin and Nigel at the IET for grappling with me for many hours on this presentation. So what are we going to talk about? We're going to look at the subject in three sectors. First, what is Formula E? Its history, its regulation, and we'll include a 5-minute video, hopefully, to give us a real feel of the close racing and skill of these new generation of drivers. Second, we're going to look at how electric racing is pushing the boundaries of EV technology. And it's nothing better to improve the breed than racing, as I've always said. And third, we're looking at the huge challenge which is facing the automotive and the generation industries, driven by this UK target to go all electric within 9 years. And we're also going to look at how we fit into the global picture. Well, let me introduce you to the founders of Formula E. On the left is Alejandro Agag. He's a highly successful city finance man. He's one-time chairman of QPR Football Club. And on his right is Jean Todt. Some of you may know him as the long-standing president of the FIA. And he was one time manager of Ferrari F1 team, who cleverly came up, both of these gentlemen came up with a formula to ensure close electric racing and an emphasis on driver skill, which is really refreshing. The story goes that they actually sat down in a restaurant in Paris and whipped out the formula for Formula E on the back of a napkin. And after a shaky start, the team gathered major sponsors and has become a great source of entertainment, as well as technical development, and incredibly educating for the younger generations. The initial grid of cars was a contract for $18 million to spark racing technology in France. And they made a superb effort to get all these cars together and put them on the first grid. And here we are in Beijing in 2014, so founded in 2011. That's some achievement. You've got 10 teams, 20 drivers, and some spare cars, all ready to race for 45 minutes around the Olympic Green circuit, which is famous now in Beijing. I'm going to jump straight into the race, not with a video, but by a still. This is just on the last lap of the race. And on the left is Nico Prost, his famous F1 father. Alain Prost was running the Renault team from the pits. And there he is driving the Renault. And on the right, my picture anyway, is Nick Heidfeld, who's been dicing with Nico for the whole race, and now is going to try and rush through on the inside. He got it all wrong because Nico was just turning left, trying to get the apex, and this is what happened. It was a flying start. Fortunately, he was fine. Landed in kick form on the track, stepped out of the car, and that says an awful lot about carbon fiber tubs and the safety of racing today. Remember, he's got quite a big lump of battery right behind him there, flying through the air. Well, it was a brilliant first championship year. There were 10 races over 9 countries. And these are all new circuits on cities. We ended up in Battersea Park with the final race in London towards the end of that year, 2014. And I think we've got a shot of that here. There they are in the park. The winner of the championship that year was Nelson Piquet Jr. That's the son of the famous Nelson Piquet. And he was driving for China Racing, and he won by 1 point from Sebastian Buemi of Renault. So it's very close stuff. But of course, the local residents didn't like it much because they couldn't walk their dogs, and it all became a bit difficult in that location. Very narrow too, as you can see. And they've now come up with a brilliant new site in Docklands. We'll have a look at that a bit later on. Going to run fast forward through to 2017-18, which was the last year of what we call the Gen 1 cars. Hong Kong replaced Beijing, and there were additional races in Morocco, Chile, Mexico. Mexico, I think, it's coming up next week this year. And race 6 in 2018 was the first race in Rome. And for the first EP, the team were invited to Vatican City. And there is His Holiness the Pope Francis, gave his blessing to the Formula E cars and the racing teams. And there's Alejandro next to him on Pope Francis's right. Brilliant moment, bit of organization. Now we're going to talk about Generation 2. This has been the first major upgrade that came in 2018. Double battery capacity, power went up substantially, and we'll see what happened. The great thing was that the battery was doubled in capacity, almost, and the size and weight are very similar. So somebody did a brilliant job on packaging a battery, and I'll tell you about that in a minute. The battery was actually developed by McLaren. It's 385 kilos versus 320 kilos for the G1 car, which only went half the race. So now you've got something that runs the whole race. And this is tremendously important, a 45-minute race, because the one thing you don't want to do is to discourage owners of electric cars with the dreaded range anxiety. And it was a vitally important PR step to have the race run in one go. There's that. That. And that just shows us a little bit about the comparative performance and weight of these two, of the Gen 2 vehicle. Substantial upgrading regen to 250 kilowatt. And that also makes an important difference to the range, of course, especially in a race where you're braking hard all the time and accelerating all the time. Very different to road cars. This was the Jaguar I-Type 3, which was launched in 2018, and it's one of the Generation 2 cars. Very successful, and although the weight of the vehicle is way up around 900 kilos, you've got to remember that an F1 car only weighs 750 kilos. So the battery is a tremendous handicap, but that's being worked on. We'll see how things are improving. Now, this is the interesting modification to the G2 bodywork. It includes a massive rear diffuser, and this gives you maximum downforce with minimum drag, because what's happening is the air is entering under the diffuser, under the vehicle, in a low pressure, high velocity state. So it's accelerating underneath the car, and of course, high airspeed reduces pressure and provides downforce on the car. And then when it exits the car under the under tray, you gradually increase the cross-sectional area of the diffuser, and the exit air gradually slows down, not suddenly, and returns to its original free-stream speed. So the aim of that is to decelerate the air without it separating from the tunnel walls and roof, which would cause a rapid moving flow stall and reduce the downforce, and in fact induce a large drag force. So there's some clever stuff there. Very important on the Formula E cars, of course, because we're trying to absolutely minimize drag. Downforce is not quite so important. You're on these Michelin Pilot Sport EV tires, which run in wet and dry conditions, and run a lot of the season. I don't know exactly how many tires they go through, but not very much. Now, John Todd, I think it was, came up with a very clever thing called attack mode, which is where drivers have to deviate from the racing line in order to activate the attack mode on their car. But they lose track position by doing that, but they gain power for overtaking. They're given up to 4 extra bursts of 35 kilowatts. Doesn't sound much, but makes all the difference. But they've got to use that energy frugally because they've only got a limited amount of battery on board, and they've all got the same amount of battery, of course. This is actually the Jaguar Formula E coming through on the racing line, but you can see in the background is the attack mode lane, where he would have to run off into that lane, off the racing line, and activate his attack mode. So you'll see that happening in the race. The other thing they did was to introduce fan boost, where the fans can actually boost the performance of their favorite driver, which is amazing. I mean, it's straight out of computer games, but I thought they were crazy, but it actually works. It makes it all very exciting because you never know who's going to suddenly come through from behind, and the whole thing is it's worked out very well. It's very entertaining. You get the key driver gets an extra 100 kilojoules of energy, which is like 20 kilowatts for 5 seconds, and he's got, I think, several bursts of that. His halo lights up around the driver when the fan boost is activated, so the fans can see it. Rather fun. Now we're on to next year, 2019, and we're in Rome again for the E-Prix. And these are the Generation 2 cars, looking all very exciting and purposeful because they're very much, they're wider track, they've got more bodywork to avoid shunts, and of course, as I said, they're doing the whole race in one go, which is so much better. They moved on this year, in February, to Diriyah in Saudi Arabia. This is a very interesting UNESCO heritage site. It's the old Saudi headquarters north of Riyadh. And race 1 was won by Nick de Vries in the Mercedes EQ, and race 2 by Sam Bird for Jaguar. But they're all done at night when it's cool, of course, by floodlight, which is brilliant. The FIA had a large part to play in that, no doubt. Jaguar actually joined the fray in 2016. I'm always talking about Jaguar because you can tell I'm a fan. And they've signed up for the new G3 series, which we'll talk about next year. And this is all part of Jaguar's sustainability program. They now have an objective at JLR to achieve net zero carbon across the whole supply chain, across the products and operations by 2039. Now that's quite a target, an awful lot to achieve, but well done, Jaguar. So let's move on a little bit to some of this night racing and some of the other cars that were performing. Here's Envision, which is one of the few companies in the UK producing lithium-ion batteries. And they're supporting Robin Friends, who's from Holland. And of course, he's backed by Virgin, Richard Branson also. They're beginning to come through later in the season, as you'll see. Weren't too good at the beginning. And then there's Team Mercedes, which feature Nick de Vries, and he's well up on the leaderboard in the championship. Those are the teams. Won't go through them all, but the key thing is you've got nearly every major auto company now involved: Audi, BMW, Citroen Group, Mercedes, Nissan, Jaguar, and they're all represented there. Now we're off to Monaco. This is the ultimate street circuit, in my view, and it's one of the few city circuits left that Formula One actually revel in. Round 7 of the championship this year was held in May on the full Monaco circuit for the first time. It's a brilliant race with lots of overtaking, attack mode, and all that. So you've got to watch carefully. We're going to try and run this clip. We're going to hand you over to Jack Nichols, who's the commentator. He gets a bit frantic at times. He reminds me of dear old Murray Walker from F1. God bless him. So here we go. I'm going to try and kick this off and let it run for 5 minutes. Time to grab another beer or whatever.
And we go green in Monaco. It's a lot of wheel spin for Pascal Wehrlein further back, and Evans has got a good getaway. He might have the inside coming into Sandervot. Locks both his front wheels. Franz tries to hang it around the outside and keeps second position. Everybody else steaming in. Rast, they're 3 wide. Coming up through Beau Rivage, and Sims is locking up, and there's a bit of contact. And coming through Mirabeau, everybody makes it through safely. Meanwhile, Roland is attacking Gunther. Now we're into the hairpin, and everybody is safely through as well, but I think someone's off. Oh, and there's a contact there. That is Sims in trouble. There's also someone off at Mirabeau. Here comes Friends for the lead. Robin Friends on the attack. He's through.
Black and gold to Cheetah through attack mode activation zone.
Da Costa from second place then activates his attack mode. There's the look from Verne. Verne is going for Evans round the outside at the New Nouvelle chicane, and Verne gets through, and Da Costa's going to get caught up in that. Evans goes straight across. Now I think he'll have to give that position back, surely. They're going to go side by side into back, and Evans comes out in front, and Gunther takes advantage and gets past Jean-Eric Verne. Brilliant wheel-to-wheel racing on the streets of Monaco. He's side by side here with Verne, and then he just doesn't take the corner and gets ahead of Verne. Surely Freitz takes attack mode this time around. Indeed he does. Race leader activates attack mode. Freitz to the outside for the lead of the race again, and Freitz is through. Robin Freitz activates his second attack mode, and it means that Da Costa is back in front again. So Da Costa has track position once more. Freitz is back through, is he? Yes. Freitz is back through ahead of Antonio Felix Da Costa. So he's taken his second attack mode, and he's in the lead of the Monaco E-Prix, Robin Freitz. Things
Oh dear, what happened?
and we go green in Monaco.
Sorry, I'm going to have to put that back on where it was. Somewhere around there, I think. Sorry about that.
And he's still got 2 minutes of attack mode remaining. He's going to be all over the back of Da Costa.
Okay, head down, max efficiency, max
He's
efficiency.
going for it now!
Keep energy under control, let's chase him.
What a move!
Evans up through Beau Rivage, takes the lead in the Monaco E-Prix. Absolutely outrageous stuff from the Kiwi.
He clearly
energy under
had his
control.
bravery pills this morning, did he not?
Rene Rast has stopped climbing up the hill, and that's an interesting position. That could bring out a safety car. He's got damage on the front, and the safety car is deployed here in Monaco.
This is a great camera angle. You see Nick Cassidy not doing anything wrong.
No,
look at the understeer,
yeah.
look at the front of the Audi, just, oh, yeah, he hit that hard.
And look at this, Evans above. I stole that off Twitter, so sorry about that. Evans goes to the right.
And at this point, he's probably thinking, yes, they're going to crash, they're going to crash.
Safety car in this lap. Mitch Evans floors the throttle. We go green in Monaco once more.
You have the fan boost to use. One more lap to
And
use
he's
it.
done it.
Side by side, and here comes Da Costa. They make contact. Evans holds the lead, desperate for his third win in his Formula E career. Gunter's round. Final lap of the E-Prix. It's going to be so close for Mitch Evans to get to the end of this. If he hangs on, it'll be one of the most remarkable drives that we've seen in Formula E. Da Costa goes for it into Beau Rivage. Da Costa to the outside and to the lead. All locked up, gets it stopped. Da Costa takes the lead on the final lap. The DS Techeetah driver hits the front. The reigning champion is going to secure his first win of the season. Robin Fries is going to try and take second because Evans is going to be so close, so marginal getting to the end. Jean-Eric Verne is involved as well. Fries to the inside. They bang wheels. Evans cuts across. There's a crunch of carbon fibre. Evans still holding on to second place. The widest Formula E car you've ever seen. But Da Costa cleared him. Da Costa comes through the final corner. Da Costa wins in Monaco.
Jack Nicholls has lost his voice.
An unreal end to the E-Prix, and Freins gets second, does he? Yes! Freins to the line!
Oh man, I just won Monaco, man. This is insane.
Antonio Felix da Costa takes the win. Robin Freins in second. Evans in third.
Well, you got me up again. Yes, what a race. Two interesting points I'd like you to take a look at. On this leaderboard on the left, this is just on the last lap. You can see the state of charge of the batteries all the way down on the right-hand side. And Da Costa, who won the race, has only 0.9% left in his battery. And that is an amazing bit of judgment. And this is what wins races. And then you can see that Evans, who's the Jag driver, he's right down to 0.5, and he actually lost out. And Freins is behind him with 1%, came up and beat him into second place. So that's the sort of thing that happens, and it's really very exciting and incredibly clever for the team managers to run this thing in that way. That, as you can see, was the final result, with Da Costa winning and Freins in second. Good stuff. This is the actual championship as it stands right now for this year. And you can see there's Freins in the top, De Vries in second in the Mercedes, and then Evans in the Jaguar third. Right down in fourth is Da Costa because he's only just starting to come through, but it's such close stuff. He's in a DS, the Cheetah car. I'd like you to show you what's happening in Docklands later this year. Well, in fact, it's in July, hopefully. As you know, the Excel Centre was turned into the famous Nightingale Hospital for last year's COVID. And the pandemic absolutely shut everything down, of course. And now it's very difficult for these races to recover because you've got limited crowd attendance and all the rest of it to cope with. But they laid out the circuit the year before, and then hopefully this year it will be used. The start-finish line is right inside the building, and it's a 2.4 kilometre circuit right around Docklands, which is very clever. It should be very exciting stuff, and I hope some of you will be able to attend. If we're finally released from the pandemic restrictions, I hope so. Now it gets exciting. This is Generation 3, the new Formula E cars that are coming out, or will hopefully be racing next year, 22-23 season. We've got a big increase in power again, another 100 kilowatts going on for race power, and another 100 on qualifying power. So in qualifying at 350 kilowatts, that's 460 odd horsepower. It's quite something. So this is the Porsche that's been committed to the G3 series next year, to be driven by Andre Lotterer. He won Le Mans 3 times, so they've got some top drivers coming on now. And this is what is going to happen to the car. None of this is actually, as far as I know, it's all in great secrecy, but this is what's happening. It's a big step into uncharted territory. The battery cell weight is going to be reduced this time by 100 kilos. Now you might say, well, that's disastrous because it's going to reduce the capacity and we're going to be running out of amps in the middle of the race. But what they've done is to increase even further the kilowatt hour capacity for a smaller battery. So we'll look at that in a second. And then it's got a whole new front regen braking system. The rear brakes, the hydraulic brakes, are now no longer used. It's all done by drive-by-wire using regen. So the whole thing's beautifully balanced. This is something that has been used in F1 before. And that's the front regen unit. It's a complete separate motor generator unit, just purely for regen on the front end. And of course, that's going to require a major redesign of the whole tub in the middle of the vehicle. Now, this is the really exciting step forward. Ultra-fast charging. We're going to have a pit stop of 30 seconds. That sounds a long time. But even at 600 kilowatts, which is almost the highest rate, it's double what we find in any rapid road car charging. Even that only puts in 4 kilowatt hours of energy. So you can see what we're up against. It's actually the equivalent of 1 liter of racing fuel in terms of energy. It's absolutely minute, but and in fact, an F1 car carries all this 1,400 kilowatt hours of energy, although it only actually gets a small amount out to the rear wheels. As we'll see here, gasoline actually carrying 60 times more energy by weight than the battery, but the gap closes right down to 13 times more energy by the time you take account of motor and drivetrain efficiency. So what electric cars are all about is motor drivetrain efficiency, aerodynamics, so you keep down the load, and weight, which reduces power right across the board. So those are the 3 things that the Generation 3 cars will be concentrating on. We're going to look at the drivetrain. We may be removing gearboxes altogether, and this could well wash through to the road cars. It already has in the form of Teslas and most of the road cars. I run a little Audi hybrid, and that has a gearbox, 4-speed, because it was a 2015 car and they couldn't get enough torque out of the motor to do it without a gearbox. But this is how things are moving on. This is the G1 Generation 1 chassis and how it's laid out. Right in the middle there is the battery box. And it's all part of the chassis, which is an interesting feature. The bell housing that houses attaches to the gearbox and the motor are actually bolted directly to the battery box. So you've got a structural carbon fiber box, which is actually part of the chassis of the vehicle, and then all the front end, the driver and the tub, is attached to the front end of that. Very clever stuff. This was the McLaren motor and controller that went into the G1 cars. You'll see that that's advanced considerably already, and we'll see how that's happening. In the motor, we have to touch on this. The old problem of induction motors and reluctance motors is that when they get to high speed, they start generating a back EMF, and that's when the torque falls right off. So you get a nice rising torque curve, but then you get the back EMF fighting the incoming voltage, and you can't get much faster than that. So what they've cleverly done at Tesla, and it's now being shared around the world, this technology, is to combine the synchronous reluctance motor on the left, which is good for high speeds, but it doesn't have any back EMF issues, and the permanent magnet motor on the right, which is good for normal speeds, but doesn't like high speeds. But it does produce a lot of bottom end torque. And that's very important in racing, of course, but also in cars, and as I was saying, eliminates gearboxes if you can. Well, it has in this case. So there's a combined setup where the magnet is inserted inside the rotor in a very clever way. That's where that piece is. And then you've got some turbo electronics, which also cancel out any back EMF that's caused by that small amount of permanent magnet. This is a huge improvement in motoring performance and efficiency. And all of that was built into the Model 3. In fact, it was the first developed for the Model 3 and also the Model X Tesla. And just to show you the chassis of the Tesla S, it's an interesting configuration where you've got the motor on one side and the converter inverter on the other, housed in a round housing, which is all to do with cooling and packaging. It's an incredibly neat package, and then the battery pack sits completely underneath the car. And one reason for building a very big car, the Tesla S, gave you lots of room for batteries. But they're very low down, of course, under the underpan, and that all works very well. Just touching on inverter technology, the Season 1 system used IGBTs. Some of your IET people will know all about that. But then as the RPM went up and higher voltages went up for the Generation 2 cars, they were upgraded to MOSFETs, silicon carbide technology. And this was the G2 inverter by Rome, which the Venturi team started on, brought in. It's using Schottky barrier diodes, SBDs, has a much higher efficiency and higher motor RPM allowable. And the result of that is you can use smaller radiators. So you reduce your frontal area and you've got a virtuous circle of improved performance. Let's just have a look at the battery box. That's the G1 box designed by Williams. So you've got two major teams, Williams and McLaren, heavily involved in all this, largely through the Occurs system, which was developed for Formula One, which also uses lithium-ion batteries, and a lot of this technology carried across to Formula E. So that's rather useful. Battery sits well down in the car there, right in the middle. And the inverter is mounted above here in the airstream, but it also has liquid cooling running through it. There's a very complicated cooling system which runs right through the vehicle. And it's of vital importance. Now we're going to look at the types of lithium-ion cells which are around, have been developed. There are two main configurations. There's this one, which is called the prismatic or pouch cell design, which is flat, and it's used by Nissan and BMW, and I think by Jaguar, and it was used by Williams in the first G1 cars. They have a very reasonably high energy density, volumetric energy density of 320 watt-hours per litre, but they have single-ended current collector tabs, and you can have problems with current density in a cell like that. Here are some of those cells being fitted to a production Nissan Leaf. This is the tubular Panasonic cell, which was developed with Panasonic and Tesla, of course. It's way ahead of the game because it's storing 700 watt-hours per litre. And it's beautifully engineered because it's got all these safety features built right into each cell. You've got a lot of cells, but that gives you redundancy. So if one goes down and drops out, it's protected current interrupt, then the car goes forward, and that keeps running, which is great. It's a Swiss roll type of construction. It's very compact, and it's got overpressure cutouts, and also I show you this fusible link, which Tesla introduced on the outside of each cell. So if something goes over current, these all blow, protects the vehicle, which is very clever. That's inside one module of the Tesla vehicle. These are the cells, a large AA cell, but they're getting larger. So I'll jump on to the new 4680 Tesla cell, which is storing 6 times the power and 5 times the energy in a bigger package. But it's beautifully designed to go right under the floor, maximize the use of that space. Packaging is everything. Here it is packaged in, you can't see the cells, but it's inside the battery pack by McLaren for generation 2, which is what the cars are using at the moment. It's a complicated bit of engineering, cooling, all the rest of it. The cooling system uses a dielectric liquid, which avoids any problems with voltages, because we're now up at 800 volts. And I just take my hat off to these guys who are dealing with those kind of voltages in close proximity. It's of course, you break it all down into smaller modules, but that makes it more manageable. But and of course for safety. But it's a superb bit of engineering, and all of this is carrying across into the auto industry very rapidly. I just want to talk a little bit. I know how I'm doing on time. I'm probably overdoing it. Here's what happens inside the lithium-ion battery. And it's quite important because this is the heart of the whole issue. We wouldn't be doing any of this racing, we wouldn't be flying drones or anything without this breakthrough that happened in the UK way back 40 years ago with John Goodenough in Cambridge. What's going on is your lithium ions are moving across when you're discharging the battery from the carbon anode here, and then they move across into the cathode, which is where the problems occur because cathode tends to be very dense, and the lithium can't get through to react with much of the material in there. So that what the breakthrough came through when John Goodenough introduced, and his team introduced lithium manganese cobalt to the cathode, which for the first time stabilized the whole charge discharge process. And you've got high power density both in and out, and very good thermal management. So it was a real breakthrough. And then along came a South African marathon runner, brilliant electrochemist called Mike Thackeray, and he introduced a further key ingredient to beef up the structure of the cathode electrode. He used lithium manganese oxide, and all this chemistry produced an incredibly rigid crystalline lattice structure, fully conductive, of course, and that allows your lithium to move right through the cathode and thoroughly react. And Thackeray found that he could shuttle well over half of the lithium from the anode to the cathode and back at nanoscale, generating very high currents and voltages. And this is what's brought us to today's lithium-ion battery. There are lots of different variations on the theme, but basically that's it. It's all down to the mechanical engineering of that structure. Now, what happens next is you've got to produce this in high volume. And in the UK now, to meet this, the motor industry is going to have to ramp up its production, and we're going to have to get the cell costs way down. Well, they are coming down, but that's where all the work is going now, in getting the cost down and the volume up. Here's Tesla's Gigafactory in Nevada. Notice that it's all solar powered on the roof, and it must be one of the biggest covered areas in the world. And the objective for this plant, and it's fully operational, is to produce 3 terawatt hours of battery by 2030. Well, that's 3 million megawatts. And if you can't, you need that sort of volume to get anywhere close to the motor industry and to make some kind of dent in the population of petrol cars. This is what's needed in the UK. The Faraday Institute in Oxford came up with a projection saying that by 2040 we're going to need 140 gigawatt hours of lithium batteries. Now, if we're going to get the car industry up to speed, and of course we've now got the 2030 target, which is making this the pressure even greater. I mentioned Envision in the Northeast. That's the only UK production of lithium, and it's only 2 gigawatt hours per annum. So, you know, this is the sort of scale we're going to have to achieve. Coventry's actually put 2 billion into a gigafactory of their own that's coming through. And an important point is that by 2027, in the UK, 55% of an electric car's value must have been built in the UK or in the European Union in order for the vehicle to remain exempt from import and export tariffs. That was hidden in the Brexit deal. So we've got our first gigafactory investment with British Volt building a £2.6 billion pound facility in Northumberland. This is going to be up and running by 2023. So it's all happening, but an awful lot has got to happen very quickly to achieve any of these objectives. This is also happening in Europe, and this is the VW plant for their cars, and they're building 4 smaller gigafactories of 240 gigawatt each, using a flat prismatic cell. They're still on the flat cell design, which is harder to volume produce, but has got some other advantages. So this is the exciting bit. The price of a lithium-ion battery pack, that's the whole pack, not just the cells, has come down by 89% over the last 10 years. And this has just transformed the whole prospect for mass market cars. But the virtuous circle is that large, reasonably priced batteries reduce the number of deep charge discharge cycles, deep cycles, that's required over the life of the vehicle, which in turn extends battery life, because battery life is determined by cycles and by age or aging. So it also, of course, allows you to increase battery power at any given current, because the rate of discharge capacity, the C rate, is lower. So it's all about big batteries. And here's some of the fantastic achievements being on the market this year. The Hyundai Kona Electric is amazingly good value. And of course, right at the top is the Tesla, which we'll talk about. But in the middle there is the VW ID3, which is doing very well at 336 miles. So this is really moving forward fast. And then you've got the effect of that big battery graphically illustrated here between a Tesla and a Nissan Leaf. That was the old Nissan Leaf, so it doesn't do it justice. But the Nissan Leaf's done 800 cycles in 50,000 miles, whereas the Tesla has only done 200 cycles. So hence you can guarantee the battery for much longer if you've got a big battery. And this is what has now come about, because the Leaf's now got a bigger battery, and I'll come to that. But they're all up around warranties of 8 years, which is pretty good, or 100,000 miles, whichever happens soonest. Now that's pretty substantial. It's getting close to, well, it doesn't match car engines, but it's getting up there. Now we're going to talk about the auto industry and how it's taking all this up. And then we'll have to look at Tesla because it's way ahead. And of course the Leaf. And then we'll come to some conclusions of sorts. Here's a dramatic example of the plunging price of batteries and the ability to increase not only the energy density that's gone on, but also increase the number of batteries because the prices come down. So the 2020 Nissan Leaf has got a 384 kilometer range against the old 135 kilometer of the 2015 Nissan Leaf. Even so, Nissan is the biggest producer in Europe and has done tremendously well out of the Sunderland plant. It was really that they went into this very early on, and people couldn't believe what they were doing, but they stuck to their guns and achieved it. And that's what their battery pack looks like under the floor. It's quite a different shape because it's got these prismatic or flat cells, and then it feeds through to a rather conventional looking motor and gearbox set up at the front end. It's a fixed reduction drive, I think, and I'm sure you'll correct me on that. And the car cost is on that particular model is down to 35k, or you can get lower than that, I believe. And you've got 160 kilowatts to play with, which is a lot of power in a little car. A little bit of charging. This is the charger used in Formula E for boosting the batteries. It'll handle up to 600 kilowatts. And then we have this Ionity network now all over Europe, which has been backed by Mercedes, BMW, and Audi. And it goes up to 250 kilowatts, which is tremendous. And it competes with Tesla on that level. This is the Tesla supercharger network, which is all over Europe. We were traveling up through France and we came across at a nice hotel this Tesla charge station. And we talked to the owner of this car, a farmer from Lincolnshire, Francis Dimmock. And he'd been all over the Pyrenees, he'd been all over, going back through Normandy and then home, with no problems in the charger network. And that was 2018, so that just shows you how far ahead of the game Tesla are. Their 40-minute, sorry, the fastest charge can be done in 20 minutes, that's 50%. But these chaps are staying in a hotel overnight, no doubt, or having a coffee anyway. So you can get away with 100% in 75 minutes, which is fine. You've got a bit of time and, of course, a lot of range. That was the very first Tesla S to hit a range around 260 miles, hugely successful, of course. And it was a credit to a British engineer there, Peter Rawlinson, who masterminded the first Model S. It grew out of Elon Musk's early master move, which was his thing, the Tesla Roadster. That's a little sports car he produced way back in 2006, I think. That was a converted Lotus Elite, or Lees, I'm not sure which. But then competition from Jaguar, Porsche, and others have pushed up that specification. And we'll see what we get to next. In between that is the Jaguar I-Pace, which is absolutely my favorite. It's got a range of 292 miles, which is pretty impressive on 90 kilowatt hours of battery. So it's got a slightly smaller battery than the top of the range Tesla. And yet it achieves that sort of 290 miles, which is on the WLTP cycle. That's the Worldwide Harmonized Light Vehicle Test Procedure, abbreviated to WLTP. And it's a realistic combination of urban, suburban, and freeway driving. So it's much more realistic than some of the earlier test cycles that we used, because they tended to mislead. And you've got to make allowance for temperature, all kinds of other things on top of that. But at least that's a good marker. It's got two motors with LG Chem 90 kilowatt hour pouch battery. Getting near the end, but I must just show you the top of the line Tesla, which is absolutely amazing. It's got a stunning performance, 0 to 60 in 1.99. That's got to be 2G or something. 200 mile an hour top speed and over 1,000 horsepower to play with, because it's got motors at both ends. And it is getting quite similar to, well, it's advanced from the Model 3, which I can't leave that out either. But there it is, and it's, what does it cost? A cool £130,000 for those who want a supercar. Can't leave out the Model 3, which was absolutely taken Tesla to, I think, the second largest motor company in the world, was behind Toyota. Certainly in capital value, it's absolutely tremendous. And my good son-in-law, Jonathan, has two of these, and tells me that he feels that automotive companies have got to wake up. This thing is so far ahead of anything else on the road, and you'll see them all around now. They're really coming into England in large numbers. It has embodied that new motor I talked about, and a lot of the new technology. So finally, we need to look at the world picture, the global picture, because it's interesting that China is very close to Europe in terms of its production. It started out many years ago with the objective of being the leaders, but it looks like Europe is holding on, and you've got the US quite far behind, but they've got other problems with distance particularly. But that's a total of 3.2 4 million cars produced annually, electrics and hybrids. Plug-in hybrids, we don't talk about the mild hybrid, which is just recycling petrol energy. I hadn't talked about hybrids at all, but it's a very important filler in this market. China, of course, is the biggest emitter of greenhouse gases, and their government push has been huge. There's a 33% subsidy on every car. No wonder they've done so well. And you can only go into the center of Beijing in an EV. Meanwhile, Tesla delivered 500,000 cars during our pandemic, and they've changed Chinese car buying. They've got their own plant out there going strong, and they're building a gigafactory there too. You've got unified charging all across China. So we've got to keep an eye on that. I'm finally going to try and draw some conclusions from all this, but it's a huge subject to cover, and I hope I haven't bored you to tears. You could always switch me off, of course, but two things. Tesla announced, when Elon Musk speaks, people listen because he is a man of amazing achievement with his rockets and all the rest. He's a true rocket man. And he claims that he will reduce battery pack costs by half within 3 years. Now that is a huge step. He claims that he will produce a $25,000 vehicle that's fully autonomous, that means can be recharged rapidly and fully autonomous like a gasoline engine. And we'll have an EV powertrain that costs less than a combustion engine. Well, that's amazing. So we're going to listen to that. And the second thing is, dear old national grid. All of this is lost if we don't have decarbonized power. And I didn't know this, but the national grid is committed to going zero carbon by 2025, which is splendid. That's a hell of a target. And maybe they will meet it, maybe they won't, but they might get close. You've got to have targets. They're predicting that 3 out of 4 generators need to be net zero, and they need to go right across the whole system, particularly relying on us domestic owners going to heat pumps and EVs. And they're going to bring hydrogen and carbon capture units into play. You've got to do that to produce some negative emissions. Otherwise, you can't make the target. But that's a very exciting news and is all part of the picture. I thought, well, if Tesla meets that claim, and if National Grid does its stuff by 2025, which is very close, my personal prediction is that Formula E will feature on the major circuits of the world with Formula One and will probably merge with Formula One by 2030. There are all kinds of legal agreements in place that protect both enterprises, but it could be that that'll change when the government directive comes into force in 2030, the all-electric UK government target. I could go on, but thank you all for your attention. I really appreciate it. And a big vote of thanks to the IET team putting all this together. Over to you, Nigel, and we've got some questions and a little bit of time left, I hope, too. Thank you.
Yes, that's wonderful, Sir John. A presentation absolutely packed with information, and you covered in the last roughly 40 minutes, not only racing, but also electronics, chemistry, and a few overexcited commentators as well. Okay, so if I just readjust the deck a little bit. Yes, so I think the visuals that you put together have been absolutely stunning. I think you talk very well to the illustrations that you provided without reading them at all, and I think that's an excellent presentation. So thank you very much for that.
Thanks.
We're going to move on to questions in a minute. Before we do that, I was wondering what your take was on the thrust from Tesla and other companies is actually to take away the driver. But I know that you're a racing man yourself from many years ago, so that sort of is taking away the driver is somewhat against the man and machine connected. I wonder what you thought about that.
Well, it's very important from the point of view of safety, because many cars already have collision control, braking, overtake. They take over the braking, they take over the steering. Even my little Audi steers itself on the lane. And if you let go of the wheel, it brings up a little notice that says, put your hands back on the wheel. So it's actually very important that drivers remain, I think. You mustn't get into the feeling that this is an autonomous car, what they call driverless. That's the wrong term. It's self-control car, which will happen. But that's for certain purposes like taxis and other things. No, I think all these aids are very essential, but I think they can be taken too far, and you would have heard of some horrendous accidents that have happened because people have, in America particularly, switched on their video and watched the movie and on autopilot. And one occasion, a truck pulled out in front and the poor guy was killed. It didn't recognize the difference between a white truck and a sunlit background. That's an example.
Yes.
So I think that sort of thing is going to have to be much more regulated. There was cases of cars running on the freeway with a driver asleep in the seat, and the police didn't know what to do. They ran him off the road in the end and woke him up. But you know, this is it's a strange world, but it has got to be properly controlled. But Teslas have done a brilliant job in introducing all this, and they're heading towards the autonomous car. But sorry, I should shut up. Another question.
No, it's fascinating, and I looking back at your illustrious history and involvement in cars and so on. Was it motorsport that originally sparked your interest in the topic? I know you were a racer many years ago.
Absolutely. I could show you, I mean, a quick shot of it. No, I won't do that. But no, I had a company called Diva Cars. We raced Diva Grand Touring cars all over Europe. And we were purchased by a wealthy Greek gentleman, John Goulandris, and he said, I want you to make electric cars. We said, what? This was in, when was it, 1970? In fact, 69. And so because he could see that lightweight, aerodynamic cars were the way to go. And he had a much longer term vision. It wasn't to do with climate change or anything else. He ran a fleet of super tankers, and he thought, well, maybe the oil's going to run out one day, so we better do something else. That was his philosophy. Anyway, that's what got me into it, and it's been an absolutely fascinating story. Over in Detroit with in the early days, we produced the first hybrid there back in 1980. It's called the Silver Bolt, and we did a lot of development work down in the Bahamas of all places. And then I got into the LA program where we won an award from Los Angeles and built them a car they wanted. They wanted 200-mile range and air conditioning, all the rest of it on a lead acid battery. So we said, no, it can't be done. We're going to have to put a little engine in. And they said, okay, do what you can. So that was the first true big battery hybrid. It had about a 50, 60-mile range on the battery alone. So we're all sitting on a big pack of lead acid. Anyway, that's another story, but that then went, as you mentioned earlier, over to Toyota, or at least the team took it up from the Tokyo Motor Show, and moved it on from there. And the Prius came out 4 years later. So that's that.
And is there a car that you can think of in all that time that you would have wanted to drive, but you never had the opportunity?
No, I'm simply focused right now on the Jaguar I-Pace. I think it's a beautiful machine. and all of the Tesla range are superb. I think I drove a lot of cars, of course, during development. We never realized how much performance you had stacked away in the battery, because we had all that power, but we didn't use it because we didn't want to run out of range. You see, it was a completely different mindset. So anyway, it's lithium's done it. There's no question that we wouldn't be here without that.
And I think your mini lecture on the chemistry of it was very illuminating. I'm
glad it's important to get right to the guts of the matter. Mechanical engineers like to know what's really happening inside a battery. It's that crystalline structure that allows this whole thing to operate, because you've got a very high active material utilization. That's the key thing with batteries, is you can have a lot of material in there, but you've got to utilize it as much as possible in order to get the performance. And that's what lithium does, apart from being a fraction of the weight of lead. I could go on, but...
Well, let's move on to some of the questions submitted by people watching, and I'll bring in Richard and Samantha. They've been monitoring the questions put forward by everyone watching today. So Samantha, I think you're going to kick us off today.
That's right. Hello, Sir John. Thank you for an excellent talk today. The first question's about batteries, about charging batteries, as you can imagine. So in respect to Formula E, is it faster to replace a battery rather than charge it?
No, absolutely not. You'd never extract that lot in under an hour or half an hour, No, charging is the answer. And if we can develop this fast charge technique, which is much higher voltage and much higher current, without causing I²R heating losses and all that, and voltage problems, this is what's going on right now. And they're hoping to have this ready for next season. So that's the answer, no question, fast charging.
Okay, and linked to charging, how is the battery charge affected by temperature?
That's a good one. The acceptance of a battery is directly related to temperature. It'll accept more charge up to a point. Obviously, you don't want to get above the top limit, but it'll accept more charge when it's warm. So the cooling systems, or the thermal management systems on these batteries is essential, because it warms the battery in the winter and it cools it in the summer, and all this has to be dealt with, because you've got to keep within a certain range to maintain battery life and to get the performance out of the battery in the first place.
Does that mean that electric vehicles are more suited to certain climates than others?
Well, you see, yes, that's true. If you go to the basics of without elaborate cooling systems, or thermal management systems, but Tesla's developed the most amazing, thorough thermal management system. It takes in the motor, so you're using waste heat from the motor and the controller to heat the battery in the winter, and then you've got to cool the whole lot in the summer. But for example, their last count, I think 15,000 Tesla S's running around in Norway. And that was, again, due to a government concession to encourage them. And everyone bought them. And you've got a very big government incentive here, which I think not a lot of people are aware of. My son-in-law, Jonathan, bought his 2 cars almost entirely out of the profits of his company instead of paying corporation tax. And that's a huge write-off. And he says he even makes a profit out of claiming mileage allowance, because the cost of running it is so low. So well done these people who have the guts to go forward and become early adopters. And the government has to back that, and they are doing it, but it's tending to favour the top end of the market, of course. Early cars are expensive.
You'd be glad to know I'm an early adopter, so.
Good for you. Yeah.
So, Richard, you want to fire off another quick one?
Yes, thank you again for a very interesting talk, Sir John. Staying firmly on the subject of batteries, we've had a number of questions about what I think some people see as the elephant in the room is, are there enough sources of lithium on the planet to supply all the battery-powered vehicles that we're being encouraged to do, and how practical, how easy is it to recycle used batteries?
Very good points, both of those. Because lithium is blended with all kinds of other manganese, cobalt, and so on, it is very difficult to recycle. And there are plants doing it, but it's expensive. And what's tending to happen is, as the battery fades, you get so maybe 20% drop off over 8 years in capacity. You've got a battery that's still got 80% of its capacity. It's down on power, but it's still got 80% of its capacity. And those batteries are being put into second use applications. And it will then go on for many, many years. And that's really the answer. The sources of lithium are quite difficult. Chile and Bolivia, they're strategic points of, and of course, China's been fighting for trying to buy up supplies as much as they can. But it's like any other commodity. If the price goes up, people dig more of it up. And it's available. It's in the ocean. They don't like that either because that disturbs the ocean. But there's lots of it around. And people will develop more and more techniques, hopefully without pushing the price of lithium too high. But it's been very high and come down again because the supplies come through. So that's what it's all about. It's like any other commodity. And of course, there are all these other rare earth elements used in these cars, copper, large degree of copper, which are around. I also often wonder about Elon Musk's moonshot. I think he's going to start mining on the moon. That was in the Engineer last week. And maybe that's where all the lithium is. I don't know, but all these things originate from meteors, don't they? In the Earth's crust. Some of them do, anyway. Anyway, I'm not a geologist, but
that's interesting. I think I declare an interest here as well. Like Samantha, I also drive an electric car, and I've got a battery powering my house, which I'm hoping I won't need to use if there's a power failure later on this evening.
Brilliant, Richard. Are you on off grid?
Well, funnily enough, in the last few sunny days, yes, barely touched the grid, which is quite a nice way of existing. So maybe that's a subject for another talk.
Okay.
Back on batteries. So lithium-ion batteries at the moment. What new technologies might there be? So some of our viewers have mentioned graphene. Others have mentioned hydrogen fuel cells, another technology that might be around the corner.
Yeah, hydrogen fuel cells are in the picture, but for certain applications like long distance trucking, I just don't think it's worth hauling around 10 tons of battery in a truck because you lose payload and it doesn't make a lot of sense. If you want 500 miles in a truck, that's what you need. But anyway, so I think that the fuel cell is developing rapidly, and that will come in for certain applications and be used in parallel. But the general view is that lithium is the magic we need if we can use less cobalt, for example, because cobalt's a politically difficult material. They use child labor digging it out of mines in places. That's what I read. That sort of thing. And the whole objective now in battery development is to come up with different combinations of lower cost materials, more readily available materials. And the other big white hope is the solid state lithium battery, where you eliminate the liquid electrolyte in there, and that packs a lot more power, longer life. It's got a lot of advantages, but there are loads of problems, and can't go into them now. But that could come through, and Toyota's doing a lot of work on that at the moment. Sorry, I could go on, but
no, great. No, I think that's another huge subject for another talk. We've got lots of material coming here, I think.
Yeah,
I was listening to an industry roundup on automotive the other day, and there was the speakers from McLaren and Toyota and Kia and a few others. And interestingly, there's a polarization that McLaren and Kia were definitely the battery is the king, and Toyota were very much hydrogen is the king.
Yeah.
And it's an interesting time to take a gamble if you're in the motoring manufacturing industry on which will prevail.
Yes, I think lithium is king, and you know, there's a huge investment. I mean, Warren Buffett put in something like $1 billion years ago into lithium battery production, and he's doing really well with that company. So I could, you know, it's a huge subject, but the big thing is volume production, as we were saying, and if you can get the volume up, then you can start really getting the cost down. And it is the elephant in the room. You're absolutely right. It's got to come down a long way. But if we can do this recycling or continued use of the battery, then you've got a much more, which is what happens with petrol cars, of course. They go on forever with rebuilds and so on. This is the kind of thing that will happen, I hope. Okay?
Okay, yeah. Next question, Sir John. At the moment, obviously, Tesla is very much the leader in terms of electric vehicles. What do you think the future is long term? Will they remain at the top, or any other manufacturers such as VW ahead?
I think they'll remain at the top, and they may start swallowing other manufacturers. They're going so fast in the right direction. I mean, if I'd been Elon Musk, he did all the right things. And he's continuing to do so, which is amazing. So yeah, they're the stars, and they're going to dominate for many years, I feel. In fact, my friend Jonathan said he feels quite a few manufacturers may go out of business if they don't get cracking and keep up. Sorry, one other point on that is that VW has done a great job on the smaller cars, and that's a whole different area. But now Tesla are talking about a $25,000 car, which is now at that end of the market. But I think the ID.3 and 4 are superb, a bit of engineering, and that's really the dominant one in that. The Renault Zoe is also well worth looking at. Is that the one you have? I don't know. Are you pure battery?
Mine is a Mercedes EQC.
Oh yes, lovely. Yeah, they haven't been around too long, have they?
No. The range is 275 on that. It's not too bad. And
it really does it?
Well, so again, it is impacted by temperature. So on days like this, yes, the maximum range is around that. But during the winter months, it's cut by about 10%.
Yes, that's quite serious. And that's actually not as much. Many of them go down by 30%. The little hybrids, particularly, the Audi I have is way down in the winter. It doesn't have an elaborate thermal management. I think that, you know, that an all battery car does. So you're much better off. 10% reduction is really not bad.
No, it's not bad.
And if you manage to charge it at the right time, so you turn the charger on at midnight and it's just finished charging when you come to use the car in the morning. Yeah. Any other?
Yes, a couple of questions here from the sort of the petrol head side of life. So, how does the top speed of a Formula E car compare to a Formula One car? And if they were to race each other on a short track, obviously, which one would win? I'd love to see that race.
Yeah. Well, the Formula One car by miles, because it's a lot lighter. It's 750 kilos against nearly a ton. But the top speed of the Generation 3 Formula E is getting close to 200 miles an hour, which it actually fits into the formulas between Formula 3 and Formula 2. It's nearly Formula 2 performance, which is stunning. If it gets there, I mean, we're holding our breath that they will actually meet these targets, because this is a target for next year, and it's all been held up by the pandemic. And one just wills them on to get there. It's I think it will be achieved, and we'll see. It's amazing what's been done. Tesla's spending $2 billion a year on R&D, and it's no wonder that they're that far ahead. So we just got to see. But yeah, to answer the question, the merging with Formula One is still a long way off. But my gosh, we got there very quickly from nothing.
Yes, I think that's one of the things that that strikes me most about the speed with it. Both the sport and domestic vehicles have evolved in a relatively short period of time. It's taken off like crazy. So that's great.
Yeah.
Okay, I think one final question, Nigel, is that okay?
Yes, that's good. Yes,
yeah.
yes.
So the government aim is to have all vehicles to be electric by 2040. So the question is, will the national grid be able to cope with all of us charging our electric vehicles?
Yes, correction, somebody's changed it from 2040 down to 2035, I think.
Oh, is that right? Okay.
With another political move. But it's easy to say it, isn't it? Easy to say it, but can it be done? Yeah, regards charging, it's not an issue. The grid are very aware of 93% of all electric cars are charged at home at night, which is brilliant because you're using off-peak power. And that takes care of a tremendous amount. The rapid charging is more of a problem. But if this 93% or 90% of that order of domestic charging continues, which it will, because the bigger the battery, the less you need to use these rapid chargers. Then, of course, you can manage the power much more readily. And even more than that, you can put power back into the grid by using your car as an energy source, which is being done. I'm not sure how practical that is, but it's being done in America, and I think it will. If it works, it'll spread because it can be used for peaking, particularly. We've got these huge peaking problems in California, for example, where people all come home in the evening, hot day, and turn on their air conditioners, and the sun goes down, and you've had it. So on come all the peaker plants and generate lots of carbon. So that's where storage really comes in, leveling out, and that's where you can use cars as your storage source. I mean, 100 kilowatt hours is a lot of battery in one vehicle. They're not all that big, but I think yours is probably what 50 or 60 kilowatt hours in the Mercedes.
Yeah, I think it's 60.
Yeah, so if you can tap into that resource, and of course you get paid if you discharge into the grid, you get paid for your power, especially as it's peak power. But the awkward thing is that you may not be at home when it's needed, and because it's going to be needed at 5 in the evening, and that sort of thing. It's a whole thing is it's a nightmare to manage. It's best to think of the off-peak charging as the real winner, because that's where you get the cheapest power and where the grid can cope.
Yeah.
Interestingly, where I am, the local town planners have been thinking about this, and I tackled them on the obvious question: how do people who live in flats charge their electric vehicles? And actually, they had rather a good answer that they're in the process of building a rather large multi-story car park, and that's equipped with charging points. So the idea is that people who come into the town to work will charge during the day when their vehicles sit idle, and those people that live in the places where there isn't enough land surrounding their immediate house to have their own charging point can also charge in those bays during the night. So it's a nice idea of a harmonious arrangement for using a relatively small number of charging points to satisfy the needs of people who basically live at home and go to work and travel relatively to other places relatively infrequently. So I don't know if that will become an urban model for those that don't have the acres of space you have in North America to put your own charging point by your own property.
Yeah, it's absolutely essential that these flats and other domestic situations can get charging done. I think my solution is bigger batteries, because you can have a gas station set up where you can only recharge once a week, or that works. You could have these street chargers, which is a bit of a nightmare because you've got to have a parking bay that's available when you want it. That's another one, and a lot of those going in London. But it is a pretty difficult problem.
But one I think that that from what you described in the evolution, we've overcome as a society so many other things that hey, it's only a little one, isn't it?
Yeah, exactly. Yeah, people will find a way. I mean, there are an awful lot of cables running across pavements, sidewalks to cars parked outside a house. Someone's got to probably outlaw that, because it's and dig a trench, or do something that's related to the house, so you can actually charge your car in the street. If you've got that, doesn't get over the flat problem, but it gets over the house issue where you haven't got a garage, and so on. I've seen cars parked on front lawns charging. I've seen leads hanging out windows, all kinds of things going on. People get around it.
So I think that's covered pretty much the questions submitted by the audience today. If you did submit a question and we didn't get round to it, sorry about that. We tried to condense them into the topics that Richard and Samantha very expertly curated for us today. So I'd just like to thank both Richard and Samantha for helping out with that. Thank you very much to both of you.
Yeah, thank you.
And again, really, it just comes down to me to thank you. I thought I'd share with you my electric car. I've got it with me here. Oh, there it is.
Very neat.
Almost one of the originals, I think, in the development of the electric vehicles. And interestingly, when you were playing your video, the sound of the motor racing is quite different compared with Formula One, and actually it sounds exactly like my slot cars.
Of course, revving up to about 18,000 RPM.
Yes.
Or more, 20. Yeah. So I'd like to thank you, Nigel, for organising all this, and all your team, Richard and Peter, and Peter Riccardo for putting this idea to me. I hadn't really looked at Formula E at all, but it's absolutely the leading edge, and thoroughly interesting. Thank you.
Well, thank you very much, and it's been a pleasure to not only hear your and look at your presentation, but also to chat with you on the various things that have been submitted by the audience and so on. So from everyone behind the scenes and in front of the camera, it's a very good night from us, and thank you very much for taking part.